Hello, today we are going to architect a neural network with the Neural Network Modeler on Watson Studio. After logging in, click New Modeler Flow. From the New Modeler Flow page, you can create two different kinds of flows. One is the traditional modeler flow, and the other is Neural Network Modeler. So we'll click that and give this a name, something like NNM Fashion seems good. Of course, you can create a new network from scratch, but we also offer a variety of examples with popular network architectures to make getting started easier. So here we'll choose a convolutional neural network architecture that we provide for you and click Create. Since we started with an example, Watson Studio has pre-populated the canvas with nodes. Roughly speaking, these nodes represent a sequence of mathematical operations which define a computational graph along with information about the location of our training, testing, and validation data. Here, we first use the image data node to define connections to cloud object storage, and then apply a convolutional layer followed by ReLU activation, another convolutional layer, max pooling, and dropout. If you followed along in the series, you know that you can use hyperparameter optimization later to intelligently build the best network. On the left-hand side, you can find all of the neural network nodes available in the modeler. We support many of the most commonly used layers along with essential matrix operations, so building your networks remains intuitive and familiar, but at the same time flexible and expressive. Let's take a deeper look inside the nodes themselves. We'll start to follow the data as it moves through the graph, beginning with the image data node. Now, we perform validation on your design to help ensure that the underlying code will actually run once downloaded. This means that any of your architectures must begin with an input data node. Here, the UI makes it easy to discover our training data in cloud object storage, and the settings dropdown provides us the tools to tweak some parameters such as the dimensions of our images, the batch size, and the number of epochs we want to run. Notice here the Neural Network Modeler supports a variety of data formats. It defaults to Pickle, but we'll change this to zip since we're using the fashion MNIST data, and we've got all of those data sets gzipped. After we're done editing the image dimensions, we'll click Save and move on. Let's open our 2D convolutional layer and take a look at some of the parameters. The Neural Network Modeler will try to make intelligent default choices for the hyperparameters for any particular layer, and this is especially true in those cases where we start a new architecture from sample, as we have here. We'll skip over the activation functions and dense layers here, but the configuration pattern is the same. Specifying the optimizer is usually the last step before downloading the code, and we'll follow that pattern here. We'll just verify that the defaults look okay and get ready to jump into the code. As we said a little earlier, what we've designed here is more of a general specification of a mathematical procedure that can be represented in many ways. With Neural Network Modeler, you can download this code in many open frameworks. Notice here that we support TensorFlow, Keras, Caffe, and PyTorch. We've chosen to stick with the theme in this series, that is working with Keras whenever possible. And the auto-generated code from Neural Network Modeler has a few advantages over the roll-your-own approach when getting started. Some of these are that you actually know the architecture will run when you feed it data, or it should, so you don't have to worry nearly as much about the input and output shapes when getting started, for example. At the time of this recording, the Neural Network Modeler code does not read the data in the format expected by the experiment assistant. That is, it doesn't check for the environment variable data_dir when formatting the file paths for the training data. While this means that you should be able to run this code on your laptop or in a more powerful notebook in Watson Studio, you will have to make some minor modifications to use this code in conjunction with the assistant. Now suppose we've inspected the code provided by the modeler and we want to construct a deeper network. To accomplish this, we'll just copy and paste the first few convolutional layers and stack them. You can seamlessly copy and paste collections of nodes. We'll just select a bunch of nodes, press the copy button, and paste. Of course, we'll need to drag the pointers to reflect our modifications, and just as before, we'll pass the image data into convolutional layers and ultimately pass that data into another convolutional layer after pooling. And that completes the introduction to the Neural Network Modeler. Use the canvas to build reproducible, error-free networks. We built the Neural Network Modeler to minimize the time it takes to get started on more complex architectures in a variety of frameworks.